May-June 2024, Paper 4, Variant 2. Question 1. A load is suspended from a thread. The vertical force on the load is 0.75 newtons. Can I find the mass? Yes, if you have the load, you can find the mass by dividing. So mass equals weight over G. Mass equals weight over G. The weight is 0.75 and the G is 9.8, which gives you a mass of 0.077 kilograms. Figure 1.1 shows the load suspended from a thread. A wire is attached to the load at point X and pulled horizontally to the right. So you have a load, a force pulling it horizontally to the right. Tension is 1.2 newtons. So we have 1.2 newtons to the right by drawing a scale diagram or by calculation. Again, you're not required to draw the scale diagram. If you'd like, you can. Can I find the magnitude and the direction relative to the vertical? Yes, can I find the direction relative to the vertical? Most of the questions are relative to the horizontal, but this question is relative to the vertical. Okay, let's first of all find the magnitude. Now we have two forces, a vertical force downwards and another horizontal force to the right. So I have a vertical force downwards and a horizontal force to the right. This is 0.75 and this is 1.2 newtons. The resultant force would be, yes, from head to tail. You started at this point and you finished at this point, so the resultant would be in this direction. Right? Resultant would be in this direction. To find the resultant, square root 1.2 squared plus 0.75 squared. 1.2 squared plus 0.75 squared. This is the Pythagoras or the Pythagorean theorem. Plus 0.75 squared. 1.4. This is the resultant. 1.4 newtons. This is the magnitude. Now to find the direction of the resultant with respect to the vertical, you need this angle. You need this angle. Okay, to find this angle, tan theta, opposite over adjacent, 1.2 over 0.75. Usually we say tan theta equals y over x, but when you need the angle with respect to the vertical, we say tan theta equals x over y. Okay, 1.2 over 0.75, or in other terms, theta equals tan inverse 1.2 over 0.75. What is tan inverse? 1.2 over 0.75. This is 57.9, which is 58 degrees. Okay, 58 degrees. Forces may produce changes in the size and shape of an object. State two other changes that the force may produce. Forces can change what? Can change the speed, can change the direction, right? Can change the acceleration. Define acceleration. It is the rate of change of velocity. Okay, rate of change of velocity. Train has a total mass of 520,000 kilograms. It accelerates at 1.1 meters per second squared. Find the time taken to increase the speed from 15 meters per second to 28 meters per second. Okay, acceleration equals v minus u over t. To find the time, it would be v minus u over a. 28 minus 15 over 1.1. This would give you a time of 12 seconds, around 12 seconds. Can I find the force required? Yes, F equals ma. Force equals ma. You have the mass, 520,000 times the acceleration, 1.1. What's 520,000 times 1.1? 572,000. Okay, 572,000 newtons. The train uses electric motors. Explain why the force on the train due to the motors is greater than the value calculated. Why is the force actually greater than that? Because you'd find that some of the energy is lost due to friction, or some of the force is used to overcome friction, right? Some of the force is used to overcome friction. If we were talking about energy, we would have said that energy is lost to the environment due to friction. It soon drops a heavy ball from a vertical height of 1.8 meters to the ground. It falls and it does not bounce. Does not bounce after hitting the ground. Describe the energy transfer of the ball stores when the ball begins to fall to when it reaches the ground. First of all, it had what type of energy? So it initially had gravitation potential energy stored in the ball. Okay, the ball is transferred or is changed to kinetic energy as it moves, as it falls downwards. Okay, then to, you can say, heat energy. Sometimes you can say internal energy as it hits the okay, as it hits the ground. Calculate the maximum speed of the ball. Ignore air resistance. Okay, we do not need the mass. Yes, because we can say gravitation potential energy equals kinetic energy. So mgh equals half mv squared. You can cancel out the masses. So gh equals half v squared. To find the velocity, we would say that the velocity equals square root 2gh. Square root 2 times 9.8 times the height of 1.8. 2 times 9.8 times 1.8 is 5.9, or you can say 6 meters per second. Okay, I guess we need to be a bit more accurate and just write down 5.9 instead of writing down 6. Say two ways that evaporation differs from boiling. Evaporation happens at any temperature. Okay, happens at any temperature. We can also say that evaporation happens only on the surface. On the surface. Figure 4.1 shows part of a container used to store a mixture of liquid and gaseous oxygen. The temperature of the liquid is negative 160 degrees Celsius. Can I find it in Kelvin? Yes, I can find it in Kelvin by adding 273. So basically in Kelvin it would be equal to Celsius plus 273. Negative 160 plus 273 is 113 degrees Kelvin. The container is made of steel and there is a vacuum between the inner walls. Say two methods of thermal energy transfer that the vacuum prevents. Vacuum prevents what? Conduction, okay, conduction and convection. Describe in terms of particles how gas exerts pressure on the walls of the container. Okay, we know how the gas exerts pressure. They move fast and random. Okay, gas molecules move fast, okay, and random, colliding with the walls, with the walls of the container, okay, changing the momentum, okay, changing their momentum and exerting a force, changing their momentum and causing a force. How does this force cause an area, or how does this force cause a pressure or create a pressure? Because you have force per unit area, okay, over a certain area or over a unit area, which is pressure. Okay? Question 5. You have figure 5.1 shows a ray of yellow light. Explain why the ray does not change direction when it enters the prism at face AB. Why doesn't it change direction as it's entering the prism at this point? Because it's moving on the normal. Okay, it's moving along the normal at an angle of what? At an angle of 0 degrees. Okay, at an angle of incidence, you can say, right? At an angle of incidence of 0 degrees. The critical angle for glass is 42. Can I find the refractive index? Okay, n equals 1 over sine c, right? N equals 1, so basically 1 over sine 42. What is 1 over sine 42? 1.5. This is the refractive index. On figure 5.1, continue the path of the light through the prism and after it leaves the prism. Through the prism and after. Okay. At this point, once it reached side BC, we need to draw a normal line and measure the angle of incidence. If you measure the angle of incidence here, it would be, okay, it would be 60, right? Yes, it would be 60, which means that this angle of incidence is greater than the critical angle. Therefore, total internal reflection would happen. At this point, it will be reflected. Okay, it would be reflected at an angle of 60, right? It reflects at an angle of 60. At this point, okay, as it moves through side AC, what happens is that the angle is now, what is the angle of incidence at this point? If you think about it, where's the normal? If you actually draw the normal, you'd find the normal moving along. You'd find the normal moving along this ray, meaning that the angle of incidence is 0. Meaning that the angle of incidence is 0. Therefore, the ray would continue in a straight line. The ray would continue in a straight line. Why? Because the angle of incidence is 0. If you want to prove it mathematically, ABC is an equilateral triangle, right? Yes, ABC is an equilateral triangle. So if the angle is 60 at this point, you'd find that the angle is 30, right? This angle is 30, this angle is 60. Equilateral triangle means ABC is all equilateral, and this point or this angle is 90 degrees, right? This angle is 90 degrees, meaning that the angle of incidence is 0, and therefore it will pass right through unrefracted, right? It will not bend. Internal data can be transferred using infrared waves in optical fibers. State 2 advantages of using optical fibers. We have higher rates of transmission. Okay. Of transmission. Okay. You can also say higher rates of transmission. You can also say that less data is lost. Okay. Less data is lost. A sound wave travels through air. Show figure 6.1 shows a pressure time graph. On figure 6.1, label 1 point to indicate the compression. Compression is when the pressure is higher, and a rarefaction is when the pressure is lower. Rarefaction. Explain why the graph cannot be used to find the wavelength. This is a pressure time graph. To find the wavelength, we need a displacement distance time, displacement distance graph. Okay, there is no displacement, there is no distance on this graph. Okay, there is no distance or displacement on the graph. The graph becomes louder and of lower pitch. State what happens to the amplitude and the frequency. Louder, what happens to amplitude? The amplitude increases. Frequency, what happens to the lower pitch? Lower pitch, it decreases. Okay? Amplitude is directly proportional with the loudness. The pitch is directly proportional with the frequency. Sound of frequency 13 kilohertz is transmitted through water. The speed is 1500. Can I find the wavelength? Yes, I can find the wavelength. Speed equals frequency times wavelength, right? And therefore wavelength would be equal to the speed over frequency. The speed is 1500, but the frequency is 13,000. Frequency is 13,000. What's 1,500 divided by 13,000? This is, yes, 0.115 or 0.12 meters. State the approximate speed of sound in air. It's around 340 meters per second. Figure 7.1 shows three bars of steel A, B, and C. Soon gives is given the three pieces of steel. Two of them are magnetized and one is unmagnetized, right? Two of them are magnetized and one is unmagnetized. How can I differentiate between these pieces? How can you find the differences? Okay, which of these are magnets and which is a non-magnet? Which is not magnetized? Well, let's start off with bar A, for example. I'll take bar A and I will approach the right hand side of bar A. For example, I'll approach the right hand side of bar A. I'll take bar A, for example. Okay, take bar A and approach its right hand side with bar B, bar B, from both its sides. Okay, with bar B from the left and right. From the left and A and right. If it repels, then you have two magnets, right? If it repels, okay, then you have, okay, two magnets. If not, okay, if not, you have to repeat with bar C, and make sure you have two magnets. Okay, make sure you have two magnets. That's it. You have to repeat. Can I repeat with the left hand side of bar A? Yes, you can repeat with the left hand side of bar A. The whole thing is that if you have repulsion, then you have two magnets. If you don't have repulsion, you could have magnets or you could have unmagnetized steel bars or iron bars. Okay. If it's only attraction, if it attracts from both sides, it could be non-magnetized. Okay. Now, figure 7.2 shows a circuit diagram of a step-down transformer. The mains voltage is 240 volts. The output power is 45 watts. The transformer is 100% efficient. Can I find the input current? Yes, I can find the input current. This has nothing to do with the transformer. Okay, it has nothing to do with the transformer. Why? Because you know that the power equals what? Power equals, yes, power equals IV. Right? To find the current, power over voltage. Power is 45 volts, 45 watts, and the voltage is 240. What's 45 divided by 240? 0.1875 or 0.19 amperes. That's it. Draw a label diagram of a step-down transformer. Label diagram of a step-down transformer. Okay, so you have the iron core in the middle. You have the iron core in the middle. On the left-hand side, if this is a step-down transformer, so you have more coils on the left-hand side, right? You have to draw a lot more turns on the primary coil and much less turns on the secondary coil. This is called an iron core. This is the primary coil. Okay, this is the primary coil. It's made out of copper. And this is the secondary coil, which is also made out of copper. Okay. Figure 8.1 shows a circuit. The circuit is designed to switch on a night light when the surroundings are dark. On figure 8.1, draw the symbol for a voltmeter measured to measure the difference across the LDR. So this is the LDR. We need to draw a voltmeter. Can I just draw the voltmeter across this way? Yes, you can. Yes, you can. Okay. The surroundings change from light to dark, right? As the brightness decreases, what happens to the resistance? The resistance increases. Okay. State and explain the effect of this change on the potential difference across the LED. When the resistance increases, what happens to the voltage? What happens to the potential difference? The potential difference also increases. Why? Because they are parallel. Okay. The voltage increases. Okay. Why? Because parallel to the LDR, meaning that they are directly proportional. Okay. Or that they increase together. Anyway. Figure 8.2 shows another circuit. Lamps A and B are identical filament lamps. The circuit is supplied by the power supply, or the current is 0.5 amperes. 0.5 amperes. Can I find the resistance of lamp A? Yes, the resistance would be equal to what? Voltage over current. What is the voltage in lamp A? The voltage is 240 volts, right? 240 volts in A and in B because they are parallel, the only devices in this circuit. If the current is 0.5 amperes at this point, if the current is 0.5 amperes, isn't it split equally in half? Yes, it is split equally in half. Why? Because they are identical. Because they are identical. So each of these lamps has a current of 0.25. To find the resistance, 240 divided by 0.25, which is 960 ohms. 960 ohms. Question 9. Radioactive isotopes that emit ionizing radiation are used in hospitals. State and explain two safety precautions. Two safety precautions. Some of the most important safety precautions that are used while dealing with radioactive sources are what? Yes, increasing the distance. Okay? Increase the distance, okay, between the source. Between you and the source. Why should you increase the distance between you and the source? To decrease the amount of radiation reached. Okay? The amount of radiation reached. Safety precaution two, another very famous safety precaution is to decrease the amount of exposure time. Okay? Decrease the amount of exposure time. Why should I decrease the amount of this exposure time? To decrease the amount of radiation absorbed, right? To decrease the amount of radiation absorbed. You have other safety precautions. Yes, you have several other safety precautions. We can say protective shielding, for example. Um, this is another very famous one. State 2 reasons why alpha emitters are not used as radioactive tracers inside the body. Alpha emitters. The problem with alpha is that they are very highly ionizing. Very highly ionizing. The second problem is that the penetrating effect of alpha is very weak penetration. Okay, very weak penetration. So it cannot be detected under the skin. Okay, wouldn't be detected. Sodium 24 is an isotope, has a proton number of 11, nucleon number of 24. It decays beta and magnesium. Can I write down the decay? Yes. Sodium Na24 and 11 produces magnesium and beta. We know that the beta is 0 and -1. Therefore, the magnesium will be 24 and 12. Why? Because -1 plus 12 is 11. The solar system includes the sun and planets. State 2 other types of natural objects that orbit the sun. What are other natural objects? You can say, for example, comets and asteroids. Okay. Say the shape of the orbits. The orbits are elliptical. Okay, elliptical orbits. Say to explain the energy transfer as the object travels from A to B. As the object travels from A to B, what is the energy transfer? Basically, when it's close to the sun, it has high kinetic energy, a lot of kinetic energy, and as it moves to B, further away from the sun, the kinetic energy decreases, but the gravitational potential energy increases. So from A to B, okay, the kinetic energy decreases and the gravitational potential energy increases. Okay, the statement, you need to say why does this happen? Due to the law of conservation of energy. Law of conservation of energy. Jupiter is 7.8 times 10 to the power of 11 meters from the sun. The speed of light is 3 times 10. Can I find the time? Yes, I can find the time. That's easy. Speed equals distance over time. You know that speed equals distance over time. Therefore, time would be equal to distance over speed. 7.8 times 10 to the power of 11 over 3 times 10 to the power of 8. Okay. What is time? It would be divided by 3 times 10 to the power of 8. This would be 2,600 seconds. 2,600 seconds. Name the galaxy that contains the sun. Milky Way. Okay, Milky Way. Light observed from distant galaxies is red shifted. State the theory that this supports. The theory is the Big Bang Theory. Big Bang Theory. Cosmic microwave background radiation is observed at all points in space. State when this radiation was produced. when did this radiation, when did, uh, when was this radiation produced? It was produced at the beginning of the Big Bang, of the Big Bang, right? Right after the universe was formed. When the universe was formed. Explain why this radiation is now the microwave region for the electromagnetic spectrum. Okay, this might be a bit tricky. Why is it in the microwave region? Why do we say cosmic microwave background radiation? Why didn't we say, for example, cosmic radio background radiation, radio wave? Or why didn't we say, for example, cosmic infrared background radiation? Why is it microwave? The thing has to do with the a little bit of the red shifting. Again, the concept of red shifting isn't that it's colored red. No, the concept of red shifting is that the wavelength kind of increases. The wavelength kind of increases. So as the universe expands, what happens to the waves? They get red shifted, or the wavelength increases. Okay, the wavelength increases as the universe, okay, expands. The waves, okay, are red shifted, or red shifted, and you might say that they kind of the wavelength kind of increases. Wavelength increases. Okay.